Hi math students, this is our introduction video for our lesson on order of operations. So first, to review what is order of operations. When we say order of operations, we think PEMDAS. This is a tool that helps us know the order to do the math in. So first, you always start with your parentheses. So if you have any math problem inside parentheses, you do that first. Next, you do any exponents in the problem. Exponents, for example, are numbers like these that tell us how many times to multiply the two. After that, you do any multiplication or division. So you multiply or divide next. And those are in the same line because if you have both, you do whatever comes first in the problem. So we go from left to right in our problem. So for example, if I see division first in the problem, I would divide first and then multiply afterwards. The same is true for these last two here. You do any addition or subtraction last, and then there's that same rule about left to right. So for example, if I see subtraction first in the problem, I would start there and then add the 3 as my last step. So for example, I have these two problems here. Anytime you see a problem like this where there is a lot of math to do, you always want to do one step at a time and you want to follow PEMDAS, order of operations. So I'm going to put that over here as a reminder of the order I want to go in, which means for this problem, I start first with parentheses. If you want to pause the video and try this problem using PEMDAS, you can do that and then come back to the video to see how you did. So starting with my parentheses, I would begin with 8.3 minus 5. We did some practice with decimals yesterday, and so we know when we subtract those, the 5 has to go under your 8, and that gives you 3.3. After you do one thing, you want to copy everything else down. So the 20 minus 4 times 3.3 plus 2. And we are done with our parentheses. There are no exponents in this problem, which means next is multiplication and division. I see some multiplication right here, so I would want to do my 3.3 times 4, and that gives me 13.2. I do my one step, and then I copy everything else down. So copy my 20, my minus sign, and my plus 2. And I'm done with multiplication and division. Last is addition and subtraction. I have both, so I'm going from left to right. So I want to start with my 20 minus 13.2. 20 minus 13.2. Don't forget to put the 0.0 there to help you subtract. And you end up with 6.8. So we've got 6.8. I do my one step, and I copy my plus 2. And then finally, 6.8 plus 2, that gives us that answer of 8.8. This is about as crazy as a problem gets. This had 1, 2, 3, 4 steps here. And PEMDAS helps us solve a lot of these problems. There are some exceptions to this rule here. For example, this problem over here on the right. So looking at this problem, if I'm using PEMDAS, and I can copy that down again for us, this time I don't have any parentheses, but I do have an exponent. So I would want to start here. I could say, well, 3 squared is 3 times 3, which is 9. So my first step is I want to copy my 5, my plus, and change 3 squared to 9 divided by 2. And so I've done my exponent. Now normally multiplication and division comes next, and this problem does have division, but notice I can't divide yet. I can't divide until I have a single number on top. So in this situation, I need to do this addition to help me do my division. So for this problem here, I would say when I add, I get 14. And now I can do my division and finish by saying 14 divided by 2 is 7. So I show this example here to show you that PEMDAS is great and works for a lot of problems, but there are situations like this where you might need to do something first to help you stay in that order. Here I needed to do the addition so that I could divide. I can't divide until I do 5 plus 9. The other thing we're looking at in this lesson is how you can use order of operations to help you represent stories. So for this final part here, we have this story that says, at a restaurant, Joe and Lisa get 2 entrees for $18 each and share a dessert for $5. They want to split the bill. And the directions say write an expression to represent how much money each person pays. Expressions look like these problems up here. They look like a big math problem, and I want to emphasize one math problem. So they're not multiple equations. They're not going to be, I need to do this math and then this math and then this math. We want to combine it together all in one single math problem. So when we write this expression, let's break it into pieces. One of the things I need to do in order to figure out how much each person pays is I want to first figure out what the total bill is. How much total money do they have to pay? I know they buy 2 entrees for $18 each, so part of my expression is going to show this cost. We're buying 2 entrees and each entree is $18. So 2 times 18, that represents how much total money they pay for the entrees. They also are buying a dessert for $5, and that's just one dessert. So if I want to know the total money they pay $18 times 2 for the food, and they also pay $5 for the dessert. Notice in my expression, I'm not writing any answers, I'm only writing the math I need to do. So if I wanted to know the answer, I would need to do 2 times 18, get an answer, and add 5, get an answer, but we are only writing the expression, so only showing the math they need to do. Together, all of this represents the total bill, the total money they pay. For my final part, I want them to split the bill. And we saw these words yesterday. Split the bill means they're sharing the cost. It means we want to divide the bill by the 2 people. So that means I want to take my total bill and divide it by 2. I cannot just write divide 2 by at the end. And the reason for that is if I think about order of operations, this would only mean that I'm doing 5 divided by 2. I don't want to do 5 divided by 2. I want to show that I'm dividing everything. I'm dividing that total bill by 2. And so the something we need for our expression to show that I'm dividing everything by 2 are those parentheses. When I put those parentheses in the problem, it means, according to order of operations, or PEMDAS, I would do this math first, the 2 times 18 plus 5, because it's in parentheses, and then at the end, I can divide by 2. If you don't have those parentheses, it means you're only dividing 5 by 2. There are 2 ways to write this. If you're writing this on a computer, you would want to write it this way. You could also write this maybe by hand. You could write the 2 times 18, the plus the $5 for the dessert. And the other way you can show you're dividing everything by 2 is kind of like this problem up here. We are dividing everything by 2. These both mean the same thing. So in today's lesson, we're going to be looking at more stories like this and how we can represent situations with one expression using what we know about order of operations. Thanks so much for watching. You are ready for today's lesson.